Okay, Jeff has asked me to, in the interest of time, just to get straight into this. So, my name is Peter Flynn. I'm the export manager from Reliance Worldwide. So I've had a bit to do overseas with the subject of lead-free, which is the next topic that we're going to cover. We've also got Paul Bonzak, who's the Managing Director of Yapco in Oceania, who of course is a big part of the certification process which will go with this. And then to finish off, I'll have Chris Galvin, Managing Director of Galvin Engineering, to discuss some of his experiences from the West in terms of lead contamination. So I suppose the point I come at is Reliance has been manufacturing lead-free product American lead-free product for some years. Big part of our export from the Brisbane and Sydney plant, the Brisbane and Melbourne plant, I should say, is in that sort of material. I wanted to just touch on this afternoon, this being the last part of the session, so I think earlier you said I'm between you and lunch, I'm between you and a beer now, so we all have a challenge to meet. We just wanted to cover off on some of the precedents that have been set, because Australia's by no means the first people to this rodeo, and there's a lot of science established in the world about how to go about this sort of thing. From a European perspective, they are starting to move in that direction, but at the moment it's what would appear to be quite confused and becoming quite parochial. And of course, things like Brexit are starting to interfere with some of the activities, but they are also heading towards lead-free. Some people will be aware of things like RoHS, which applies to electronics, and potentially apply to lead-free to brasses and plumbing in years to come. So from a first point I'd like to make is one of the things I've noticed in the US, working with them for many years, is the concept of regulatory certainty. I find the US is a lot more an environment which stimulates and encourages investment a lot more, because people are aware some years in advance of what's going to happen, and be it energy efficiency or whatever, they'll then spend the money, do the research and development, make the investments and come up with a product. Of course, we've all seen issues like pink bats and so forth in Australia as an example of how regulatory uncertainty can generate some pretty seriously bad outcomes. So the most obvious precedent is the US adoption of lead-free brass, and that started with, like a lot of things in the States, with California with AB 1953, which was signed into law by the Governor, Arnold Schwarzenegger, on the 30th of September 2006. They decided to go it alone, as they often do, and with an effective date of January the 1st, 2010. They changed then the lead-free definition to now be less than 0.25% of weighted average of the wetted areas, which Paul's going to talk about in some more detail in his presentation. But established pretty clear guidelines as to what they wanted, and this applied to all sorts of things from lead drinking crystal wine glasses all the way up to plumbing products. A couple of other states, Vermont and one other that escapes me, Massachusetts I think it was, followed suit. So much so that in the federal bill was passed, it was signed on in December the 6th, 2010 by President Obama, with a further effective date of January the 4th, 2014, which basically enshrined the whole same regulation of less than 0.25% being the requirement. In both cases, a minimum of 36 months was allowed for compliance. Behind that, of course, the science was also developed in terms of, which Paul will talk about further, NSF developed standards in terms of leaching, testing and approvals to go with all this. But there was a pretty clear statement up front as to just how they wanted to go about it. Which I suppose in the Australian context, I want to leave something with you, is that they're talking about 2022 NCC as being a compliance date. If we were to follow the US precedent, we need to really have this nailed down by next year, which isn't that far away. The other thing that was a feature of the US experience was that it was a point of sale, effectively a point of sale legislation or regulation. The wording and the effect were quite specific. It was, you were no longer able to supply. So California AB 1953, for example, led off with the words that no person shall introduce into commerce for use in California any pipe or plumbing fitting or fixture intended to convey or dispense water for human consumption through drinking water or cooking that is not lead-free, under the definition that I showed you earlier. So it's pretty clear that as of midnight on the night that happened, that came into effect, that you were not going to be able to sell this product or do anything with it. Interesting enough, places like Canada, as this journey continued through into the federal regulation, Canada realised quite late in the piece that guess where all the trucks full of leaded product were all going to go. So they effectively brought in their own similar mirror legislation in 2013, which they've been having some difficulty, I believe, in enforcing ever since, because they realised what the outcome would be. So we also run the risk in Australia without a proper point of sale enforcement of having warehouses full of cheap leaded product that can be legally on-sold, which is all stocked by midnight on the date of transition, unless it's actually applied like the Americans did in the point of sale. And I think that was a big issue that, you know, from our own experience we faced as we went through changing our product range for the states over, that we had to make sure that the supply chain was cleared out, which I suppose, if, you know, some of the people in the room will understand is not an easy task in itself. I think the other lead point I'd like to leave on this is that cost precedents were set. Lead-free is not a matter of changing the paint colour. This is changing the whole structure of the product. It's a pretty seismic shift in how we introduce any sort of, especially brass-type product. Will come at a cost to the industry and to the community. In the US, the experience was roughly as high as 20%, 15 to 20 seemed pretty typical. Potentially, if we were to follow similar regulations with similar technical requirements, then the science is already established and the supply chain is quite well developed now. And a lot of people ask, why is lead-free brass more expensive? Many reasons. It is it's harder to recycle cheaper lead-contaminated scrap into new products. You need more virgin materials, which come at a cost. Scrap being a cheaper product than virgin material. It's harder to machine and process. One of the uses for lead is to make brass easy to work and form, for example. Without that, you start to get into other sorts of constituents, but it still becomes hard to move, and quite often you'll need more horsepower, more equipment, higher spec equipment to make it work. Also, of course, will involve significant investment in design, testing, approvals, which I'm sure Paul will talk about, and processes. Segregation becomes a bigger issue because contamination cannot be tolerated. And the logistics, of course, in cleansing the supply chain, early compliance and the cost of redeveloping the existing products will have to be factored in there. So the Americans picked 0.25% as a sensible, cost-effective level. I think the other point is that if we were to go further than that, then we're on our own essentially in world terms as to what, in terms of supply chains. And I think Carol Grossman made the point earlier about people wanting to send back product without the correct labelling under wells now. We'd have exactly the same issues unless it was clear that, you know, the supply chain had to be cleansed or gets back to the point of sale. On the approval side, which I'm sure Paul will talk a lot more about, effectively means that the majority of products on the market today will need to be redesigned, resourced, redeveloped and manufactured. One of the issues in the States, of course, the 36-month lead time, transition time, was partly to cope with the physical ability for test and the number of test labs able to do the testing. There were significant queues, as I recall, formed at the time, and much as I'm sure a lot of people would like to transition sort of literally overnight, it's going to be, there's a practical issue in getting approval testing done. So those are just some of the take-home points that I took out of our experience going through lead-free, transition to a lesser lower lead material. like now to hand over to Paul so he can start going into some more of the...
Well, thank you very much. We were initially asked, APMA was initially asked if they would have an American come out here and talk about lead-free certification in the United States. That was my boss, and he hand-passed it to me. I'm not an expert in the history of lead in brass in the United States, but I have about a 45-minute presentation in front of me, which I'm going to go through very, very quickly. So some of the detail won't be there. But when I read through this, and I thought, well, I better learn something about it, what I realised was that we have things to learn from the American experience. And the problems and the issues that they have faced, and they do face, we have the same issues that we need to address. First of all, they defined, lead-free. They had to go back and talk about it. Now, prior to 2014, there was a definition of lead-free for solder and flux, which was 0.2%, and for pipes and pipe fittings was 8% of the percent lead of the component. After they changed that, they realised that's a bit high, so they turned around. The federal government in America, so they're very much like us. They have a federal government and states. States have their own autonomous control and their own autonomous legislation, as we do very much in Australia. So they said, okay, well, we'll agree with the 2% lead percentage for solder and flux, but then we'll look at lowering the standard, which they worked out as, we just said, to 0.25% lead when used with respect to wetted surfaces. So the areas that the water touches, obviously, goes through. So the outer casing of something can have a higher lead content. But when it contacts the water, it had to be 0.25. And from my understanding, this was done for economical reasons, and that they could use that. And one thing I think that we just talked about, was just raised, was that, by Peter, was that if we decide to change that, then we need to understand that we go it alone for what we're producing, and that's a very difficult thing to do. Legal regulations for plumbing products. Moving right through, I'll just move on to, this was, initially, it started in 1974, so it's been over 40 years the Americans have been looking at reducing water. And I'll put a number of time frames and show you that different things happen. For older people like me, you might remember this bloke, Gerald Ford, and he signed an agreement in 1974. But it wasn't accepted, as I say, by all states and territories, all states throughout the United States. They have to individually accept it. Remind you of anything? Similar in Australia. So that was 86. Then we had a blue screen. Thank you very much. There's the boys in the back. Anyone know where he sat down in the back?
That was Obama.
Ooh. Right, here we go. Do I keep pushing?
Yep.
Right, we had Jerry, we're done here. So then we had, if you remember him, the old actor Ronald Reagan. And he then developed another agreement and amended and prohibited the use of pipe solder flux that was not lead-free in public systems. So that was in 86. Then in 1996, the Act has been made it unlawful for anybody to introduce into commercial items that are not lead-free and require plumbing fixtures and fittings, endpoint devices, to be in compliance with the voluntary lead leaching standards. 2006, good old Arnie, he came along, and in California, he implemented the Californian Health and Safety Code section, and I won't go through all the numbers and legislation of it, but they basically raised the bar and again defined the lead-free to mean no more than weighted average of 2.5 in lead. So it was put in by the federal government put it in, then the state started to put it in California as well. I'll go through this further. He also put in the mandatory third-party certification by ANSI accredited certification body is required to demonstrate compliance to the law. This is really interesting because that's not a federal requirement. So you don't have to have third-party certification under the federal legislation, but under the state legislation, you do. Then a number of other acts came about. We went through, and different states and territories started taking up these requirements of lead-free and to try and keep consistency across the United States. So there was the Vermont, as I'm told, lead reduction law. Then in 2010, we had the Maryland House bill that was signed by Governor O'Malley in 2010, as I say, known as the Maryland Plumbing Act. What's happening there? Just on that, you can see the issues that we face as they faced. In that, you know, we have federal legislation and then we have state legislation, and sometimes they don't marry up at the same time and with the same requirements. And if we're going to achieve lead-free, an agreed lead-free, it's something that we have to do. We have to make sure that it's a consistent Australian view on lead-free. Then we got to Obama, and he brought in some more regulation and signed what was known as the Reduction of Lead Drinking Water that became effective in 2014. Now, I'll move through. The law, just on that, Congress, federal government, intended to would broadly apply to pipes and plumbing that would provide water for human consumption, so that lead in the wetted surface of these conveyances can be minimalised or eliminated, thus reducing exposure to lead in tap water. So that was their intent. They wanted to minimise the lead in pipes and fittings right throughout the states. But not everybody went along with it at the same time. Now, you'll see what happened was there was key changes, and I'll keep moving through this, until 2012. The Maryland Plumbing Act became effective of 2012. Louisiana down south signed into the law by Governor Durrell on the 29th of June 2012, and that's known as the Louisiana Act. So what was happening was that we had this federal direction, and then each state would accept it and put it into their legislation. 2013, we talked about the Louisiana Act, which became effective for, they say, lead safe. I'll move on to now, to 2014. And even now, the federal law versus California law, which sounds contradictory. If you have a look at that, you'll see that even today, there are different requirements for lead-free brass in California and in federal law. And one of them, which staggers me, under federal law, as I said before, third-party certification requirements, it is not required. So how do you know that it's lead-free? It's a promise by the supplier that it's a lead-free product, and surely that's going to happen. But in California, if you want to sell it in California, you then have to have a certification. You'll see that the different fittings and products, it's quite extensive, the California law, in comparison to the federal law. Even the test methods of how they test for the brass in the lead is different between California and between the federal. Now, just to sort of sum that up, and I'm sorry that was very quick, but I was given 6 minutes. However, the issue is that if we're going to address this, we need to get together, we need regulators, governments, industry representatives to come together and get a consistent requirement and a consistent set of standards that we adhere to. So we're all on an even keel and an even playing field. And that's the next step. Now, if we're not going to do that, we're just going to repeat the problems that America has experienced over the last 44 years, I think it is. There we go, yeah. So you know, we can, we've done this before, this type of thing, we can get together in groups, we can have representation. Look at the people here that have spoken here today and aren't here today. They're the people that can help us and can get these decisions made, but we need to have some sensible dialogue and to set the standard. What is the standard? What is the requirement? You know, in Australia as a certification organisation, I've had situations where some certain states will accept a certain standard and another state won't. And I won't go into the detail, but I know one organisation was testing product wasn't an Australian standard yet, it was accepted by a state government. So we need to get this consistency, we need to get an understanding of what the standard is, and we need to set it for the future. So, thank you very much.
G'day everyone, if you haven't met me, my name's Chris Galvin from Galvin Engineering. We're a West Australian manufacturer of specialised taps and fixtures for the commercial market. There's been a lot of technical information, so I'm not going to go over that. This is a little bit more about our experience in Western Australia and what we went through over the last 18 months. Orange button, right? Hey. So my talk is probably a little bit redundant because when Jeff spoke to me, which was last year, all the media that was going on, a lot of it was based in Western Australia. And the media was really questioning what the safety of our water supply and plumbing systems were. So we had situations in the Perth Children's Hospital, which everyone's aware of, but that then spread through to schools, public areas like parks, and the latest has been our stadium, which some of you might be aware of. So that's been, as a local manufacturer, that's been quite concerning for us. It's something we wanted to get our head around. I've been in the industry for 25 years, and it's not something that's really been talked about a lot as an issue that we have to consider. So it's a bit more like this. So, you know, we've got Channel 7 reporting in Sydney. Last week we had reporting, I think that was a Channel 9 one, but it was run on several stations in the paper about Geelong. And of course everyone knows about the Aldi situation. So we're not only sending our GST over, we're sending our lead issues. So that's the payment. What are some of our learnings? And really these are just learnings that we went through trying to understand the issue of lead in water when all our products have gone through pretty strict compliance processes like other people in this room would have. I guess one of the first things we've had to deal with is the confusion over what this number means, and I think most people would know where this number comes from. If you don't, it's the maximum allowable concentration of lead in drinking water, and it comes from the Australian Drinking Water Guidelines, and they take that from the World Health Association. That number is actually based on a high risk group. It's not meant to be, that's meant to be highlighted, not blotted out. But, there you go. So basically that's really worked out based on a high risk group, so small children and so on. And it's really the amount of, I guess, the lead per litre that you can consume in a day without building up lead retention. That actually says, the highlighted bit actually says that 80% of lead intake comes from food, dirt and dust. So we're talking about the 20% here. So I guess the confusion is what that number's been used for. Like a lot of political handballs and media things, it's been used for different reasons. And there's different views as to whether some experts say that's the maximum individual finding you can have for lead. Others are saying, well, that's really the amount you should be consuming over a lifetime, and anything over that would be unsafe. So I guess really for us, you know, what we thought going through this issue is that you really need to understand the uses and the usage patterns. That's really important. We do need to understand the long-term health findings, because it's a bit unclear. So I guess an action there is agreement on the actual health issue, but by who. Next up for us, it was the actual confusion over the infield water testing methods, and these testing methods were affecting public opinion, but there was many varying ways of doing this, and it's possible some of the techniques used aren't actually right or generating the right data. To make it more confusing in the paper, when there's little stoushes going on, people do tend to claim they comply to AS 5667.5. If you're bored at night and want some enticing reading, I suggest you download a copy and read that. But it doesn't actually say a lot about, it's not that prescriptive. So it's quite silent on things like stagnation periods, volumes, and so on. How do I go back? The back button. Oh, very clever. So I guess for us, what was hard to understand is in AS 420, which once again is enticing reading. That's very prescriptive about what you do to get through your tests, whereas 5667 is quite either silent or vague on things like flushing, stagnation periods, volume of water extracted, and site-specific issues. And they do, from what our reading tells us and what other experts say, do have quite a big effect on levels of lead in water. That's just a flow chart of, say, a standard, and if you can't read that, the standards do break down to what sort of materials you can use. We have the zinkification resistant, and once again, that highlighted bit there is actually 420.
Believe it.
So I've learned something, I'll never do that again. Use that highlighted. So I guess for us, that's another key learning. You know, we really think that standards should be tightened up, a bit more prescriptive, and therefore people can't really start using that to for their own purposes. And I guess the final learning we had, what I'll leave you with, was just confusion over what affects lead levels in water. Like a lot of people here, I've done a lot of reading from around the world, and there's just so many things that affect levels of lead in water. There, you can read those there, but things such as materials, that's just one of the things. There's the age of the plumbing systems, the complexity, stagnation, flow rates, dead legs, chemicals, chlorine, that's certainly been a factor at Perth Children's Hospital. pH and alkalinity, it looks like low pH or high acidic water affects leaching of lead. And then just things like the build-up of protective inner linings, inner crustings over time in pipe work, as they found in Flint in the USA. So there's a lot of confusion. There's confusion between people in Australia, but there's a lot of people researching this. Health Canada do a lot of work. There's the USA's EPA, the German Ministry of Health. I was going to write the German way of saying that, but I thought I'd get that wrong. There's a lot of good research in Australia, Macquarie University, but from what we're reading, there's still a lot of work to be done there. So I guess the final action is agreement on what are the main factors affecting lead levels in water. As I say, that talk is probably a bit redundant because we've probably moved past that to changes in material, but there were some of the things we learned. And thanks for listening. Feel free to call.
Okay, so I suppose in summary, we've heard a bit about what's been done elsewhere, and as Chris highlighted, a lot of sorry, yeah. There is a lot of environmental factors in there, but there is fortunately some science and supply chain issues to fall back on around the world. So I think at that point I'll just open up for some quick questions.
Yeah. Under the American legislation, there's various plumbing fixtures that are exempted from being lead-free. For example, shower valves, urinals, toilets. In fact, there was a couple of slides in your presentation, Paul, that had that. I imagine that would cause issues with different products, in the US having to be lead-free and others not. Peter, I'm wondering if you have any feedback on the US with that.
Look, and also from Australia with a couple of discussions with Neil Sobey, but obviously the devil's in the detail, and I think at the appropriate time, indications are we need to make sure we are engaged to, things like toilets, for example, don't need to be lead-free. Other products you mentioned there. But I think that's the sort of area where it comes down to. The one thing I like, the Americans seem to have come up with a fairly clear statement of what they want. There does seem to be fairly recognisable, and I suppose the difference in the approval system over there is people like the APMO actually do the approval and protect their mark. So sure, it doesn't say you must have this, but to get the APMO approval, you will have to demonstrate compliance with NSF, otherwise they won't accept it. But yeah, it then gets down to the exemptions and all those things. So I think that's part of the conversation we have to have as we move into. I think the indication is that this will start to appear in the PCC meetings coming up in August. So industry will start to see what their intention is in that 3-year cycle leading up to 2022. And we have our chance to answer these sort of questions or add these sort of comments. Mr. Fisher.
Peter, with respect to the low level lead alloys for the US, dezinkification resistance and low level lead alloys as they sit, given that we have a strong and have had a strong DZR requirement for a number of years, is there a relationship in current alloys available that you would see if we were going to a low lead brass that would meet current requirements?
Look, I think our experience is they're not mutually exclusive. Like anything with dezinkification, it takes careful treatment of the material, appropriate treatment of the material. And even looking at some of the European regulations, some of their materials are moving to high copper, which by nature tends to be more dezinkification resistance. But once again, as I said before, I think this is, as we see what comes out in the PCC documents, we need to make sure we don't lose those issues.
We found alloys available that are both DZR and lead or low lead, acceptable by the US and Europe. They're available in the market now, and the price point of the extra was in the 20% extra vicinity.
Things like eco-brass and
Similar to that.
yeah, similar things. Yeah. Anybody else?
Well, given the nature of the mandatory certification scheme in Australia, is it your expectation that the application? Is it your expectation that the application of products that need to be lead-free will be much more wide-ranging in Australia than what was required under the federal law in the US?
Yes, I would actually. Going back to the point that was raised before, I think some of the exempt product that I can understand from reading this document concerns me, in that obviously a toilet pan doesn't have to be lead-free, but some of the fittings that go onto that could be utilised in other installation parts. So I think we have to be very, very careful in what we have exempt and what we don't. And it's a similar thing with the watermark at the moment, where we have some products that are exempt from watermark, or some that aren't watermarked, some that are, and it can be confusing. People can use them for installations that they shouldn't be. So my expectation is that we would have to be very, very careful on developing the list of exempt product.
Any other questions? Okay, I think we'll wrap it up there, and thanks very much.